Okay, this is a presentation I gave to second grade teachers. So we're doing double digit addition, but the strategies start off in first grade. And the names that I give them here are pretty common names. They were the names that we agreed upon in our last district that all the teachers would use. They should be pretty familiar with these in your district as well. So here we go. So if we start at 12, if we're going to add friendly numbers, a friendly number is typically a multiple of 10. So we start at 12 and we want to add 13. So maybe we add, 10. That's a friendly number, which gets us to 22. Okay. And we need to add 3 more. Now kids can add 1, 2, 3, or they can just go ahead and add 3 in one motion. I'm going to go ahead and do what a typical second grader might do. So add 1, 2, 3, which would get me to 23, 24, 25. There's my answer. Okay, here's another one using the friendly number method. So we want a 12 and then add 9. So we start at 12. Well, if we add a friendly number of 10, that gets me to 22, but we didn't want to add 10, we only wanted to add 9. So we can jump back and get to 21. And there's our answer for 12 plus 9, adding a friendly number and jumping back. Okay, now going to a friendly number. So we start at 12, and a friendly number would be, again, a multiple of 10. So let's go to 20. So that's adding 8. But we needed to add 13. So a typical second grader might chunk it out by ones. So if we add 8, 9, 10, 11, 12, 13, right? We've added 1, 1, 1, 1, 1. So that gets me to 21, 22, 23, 24, 25. Okay, now these are a little bit more advanced, the give and take. So a give and take would be, all right, well, I want to add 12 plus 11. So I might add 1 to 12 and subtract 1 from 11, which would give me 13 plus 10. So 12 plus 11 is the same as 13 plus 10, which gives me 23. Give and take. Place value splitting is getting us very close to the standard algorithm. So with this, we're going to take, we have 10 and a 10, and that gives me 20, and a 2 plus a 1, which gives me 3. And I'm going to go ahead and add those down, 23. But notice we're being very careful about, this isn't a 1, it's a 10. This isn't a 1, it's a 10. Okay? Where with the standard algorithm, we sort of lose our concept of place value because we're just adding digits, 2 plus 1, 1 plus 1. Right? There's a subtle difference here, 10 plus 10 versus 1 plus 1. That's why we want to start with this, base 10 blocks or place value splitting, before we jump to this. But we can build up with all of these before we get to here. Okay? All right, let's take a look at subtraction. All right, so here we're going to go, again, we'll go ahead and model these with on the number line. So with this, we're going to think about 23 minus 7 as the removal of 7 from 23. So on the number line, we're at 23, and we need to remove 7. So removal of or two friendly numbers. So let's see, if we want to get to a friendly number of 20, we're going to remove 3, which gets me to 20. So I remove 3, I need to remove 4 more. Now a typical second grader might remove by 1, 2, 3, 4, which gets me to 16. Okay. We want to push them to start removing in bigger chunks, so maybe you go minus 3 and then minus 4, which gets me to 16 as opposed to by ones. All right. Okay, let's take a look at removal, jumping back to a friendly number, and then adjusting. So here's 23. Jump back with a friendly number. So let's go ahead and we're removing 7. So let's remove 10, which gets me to 13. But we removed too much. So we want to add back 3 more. So we might go 1, 14, 15, 16. Right, this was plus 1, plus 1, plus 1. All right, same concept, except we used our friendly number to get there. All right, now this, finding the difference, is a completely different way of thinking about subtraction, where we're not removing, but we're trying to find the difference between the numbers. Some people automatically think about subtraction as removal. Some people always think about subtraction as finding the difference. We want to stretch their brains, however, so they can think about it both ways. One way will typically be harder than the other for an individual. So, adding it up. So we want to find the difference between 23 and 7. So let's start at 7, and how many does it take to get to 23? So again, we'll use our friendly number concept. We'll add 3 to get to 10. We'll add 10 more to get to 20. And we'll add 3 more to get to 23. So my answer, where's my answer? It's up here. So it's 10, 11, 12, 13, 14, 15, 16. It took 16 units to go from 7 to 23. Okay. So if we want to think about finding the difference of taking away, so if we're at 23, right, and we want to find the difference, how much does it take to get to 7? Subtract 3 to get to 20. Right, we're at a friendly number. Take away 10 more to get to 10. And take away 1, 2, 3 to get to 7. Again, here's my answer. It took 16 units, right, to get to 7. All right. 2 very different ways to think about subtraction. Depends on how the student sees it. Okay, place value splitting. Now this is a little funky. Place value splitting, we've got 23 minus 7. So let's go ahead and do this. We're going to split it up into 20, and we're going to take 3 minus 7. And this has no place value, so it's 20 minus 0. Well, 20 minus 0 is 20, right? And 3 minus 7, well, I can't take 7 away from 3, so I have minus 4. Right? This may not be useful for 2nd, 3rd graders, but some of them might understand it. So I've got 20 minus 4, 16. Okay. It might be a little easier for them if it was 27 minus 3. Okay. But this is kind of cool, right? All right, and that leads us right to the standard algorithm. So this was the whole borrow and carry here. So we can't take 7 from 3, so we have to borrow 10 from the tens column. 13 minus 7 is 6, and we have 1 minus 0. Notice we're not talking about place value here at all. We're just subtracting digits. Here we are maintaining place value. 2 sort of advanced concepts. We've got take, and give, which sort of more mathy name is constant difference. So we want to maintain the same distance, and I'll show you what that looks like on a number line too. But let's say we don't want to work with 23 and 7. So if we take 3 away from both of the terms, I've got 23 minus 3 is 20. 7 minus 3 is 4. So this problem, instead of 23 minus 7, it's 20 minus 4, which is 16. So what does that look like on a number line? So we have 23 and we have minus 7. So instead of 23 minus 7, let's move these numbers on the number line to friendlier numbers. So I'm going to move this 3 units to 20, and I'm going to move this 3 units to 4. So now the difference between 23 and 7 is the same as the distance from 20 to 4. Okay, that's why we have to subtract 3 from both. Now, give. This actually might make a little bit more sense with these two numbers, the give strategy. I want to turn that into a friendly number, a multiple of 10. So I'm going to, how do I get 7 to 10? I'm going to add 3. 23 plus 3 is 26. 7 plus 3 is 10. So now I have 26 minus 10 instead, and that is pretty easy. 16. Okay, so again on the number line, what does that look like? Well, we had 23 and we had 7. So instead of doing 23 minus 7, finding that difference, we're going to add 3 to get this to 10. And we're going to add 3 to maintain the distance to 26. So 26 minus 10 is the same as 23 minus 7. Again, that's a little bit more abstract and higher level thinking, but it is a strategy. That's it.